Imagine drifting through space. No sound, no air, only darkness scattered with distant points of light. Ahead of you, one of those lights begins to grow brighter, larger, hotter. It is no longer just a point in the sky. It is a star, a massive sphere of plasma, powered by nuclear fusion, releasing unimaginable amounts of energy every second. What would happen if you fell into it? Would you burn instantly? Would you even reach the surface? Or would something far more complex occur? To answer this question, we must understand what a star really is. What is a star? A star is not a solid object. It is not something you can stand on. A star is a vast sphere of hot, ionized gas known as plasma. The closest star to Earth is the Sun. Inside stars, nuclear fusion converts hydrogen into helium, releasing enormous amounts of energy. This energy creates pressure that balances the force of gravity. This balance is what keeps a star stable, but it also creates an environment that is incredibly hostile. Approaching a star as you begin to approach a star like the Sun, the first thing you would notice is the light. It would become overwhelmingly bright. The intensity of radiation increases rapidly as you get closer. Even from millions of kilometers away, the heat would already be lethal. At a distance comparable to the orbit of Mercury, temperatures would be high enough to destroy spacecraft, not specifically designed for extreme heat. As you move closer, radiation becomes the primary threat. Not just visible light, but ultraviolet radiation, X-rays, and charged particles streaming outward in the solar wind. Your body would absorb this energy. Temperature would rise. But something important happens before you even reach the star. There is nitrogen monoxide surface, unlike planets. Stars do not have a solid surface. There is no clear boundary where you suddenly hit the star. Instead, density increases gradually. The visible surface of the Sun is called the photosphere. It looks like a surface, but it is actually just the layer where light escapes into space. If you were falling toward the Sun, you would simply pass through this region. There would be no impact, only a continuous increase in temperature and pressure, extreme heat, and plasma. At the photosphere, temperatures are around 5,500 degrees Celsius. Hot enough to melt and vaporize almost any material instantly. Your body would not survive anywhere near this region. Long before reaching it, you would be exposed to lethal radiation. If we imagine an indestructible observer or a common approach in physics thought experiments, we can continue the journey. As you descend deeper, temperatures rise dramatically. Below the photosphere lies the convection zone. Here, hot plasma rises and cooler plasma sinks in massive currents. Deeper still is the radiative zone, where energy moves outward through radiation. Temperatures increase to millions of degrees. At these temperatures, atoms cannot exist. Electrons are stripped away from nuclei. Matter becomes a plasma of charged particles. The core of a star at the center of the Sun, temperatures reach about 15 million degrees Celsius. Pressure is immense. This is where nuclear fusion occurs. Hydrogen nuclei collide and fuse to form helium. This process releases the energy that powers the star. If you could somehow reach the core, you would encounter one of the most extreme environments in the universe. Matter is compressed to densities far greater than anything on Earth. Energy is constantly being generated. Radiation is intense. No known material structure could survive these conditions. Different types of stars. Not all stars are like the Sun. Some are much larger. Some are much hotter. Some are far more extreme. For example, massive stars can have surface temperatures exceeding tens of thousands of degrees. Red giants expand to enormous sizes, engulfing nearby planets. Neutron stars are so dense that a single teaspoon of their material would weigh billions of tons. If you fell into different types of stars, the experience would vary dramatically. But in all cases, the outcome would be the same: destruction. The role of gravity as you fall into a star. Gravity accelerates you. The closer you get, the stronger the gravitational pull. For a star like the Sun, this acceleration is significant but not extreme compared to more compact objects like neutron stars or black holes. However, combined with radiation and heat, gravity ensures that escape becomes impossible once you are too close. What happens to matter? One of the most fascinating questions is what happens to matter as it enters a star. Atoms are broken apart. Electrons are stripped from nuclei. At high enough temperatures, even nuclei can be affected by nuclear reactions. Matter becomes part of the star's plasma, in a sense. You would not simply burn. You'd be completely transformed. Your atoms would become part of the star itself. Eventually, some of that matter might participate in fusion reactions. Over time, it could even become part of new elements created within the star. Comparison with other cosmic objects falling into a star is extreme, but it is not the most extreme scenario in the universe. If you fell into a black hole, you would encounter phenomena like extreme space-time curvature and tidal forces. If you fell onto a neutron star, the surface gravity would crush matter instantly. Compared to these objects, stars like the Sun are less extreme, but still completely lethal. Timescale of destruction, the process would not be slow. From a human perspective, it would happen almost instantly. Radiation exposure alone would be fatal long before reaching the star. Thermal destruction would follow rapidly, at atomic levels. However, the transformation continues deeper into the star. Conclusion: becoming part of a star. So what happens if you fall into a star? You would not land. You would not stand. You would not even reach a defined surface. Instead, you would be gradually destroyed by radiation, heat, and pressure. Your atoms would be stripped apart. Your matter would merge with the plasma of the star. In the end, you would become part of the star itself. And in a much longer cosmic timescale, the elements forged in stars can be released back into space, forming new stars, new planets, and perhaps, one day, new life. In that sense, falling into a star is not just an end. It is part of a much larger cosmic cycle.